Hi guys, today we're going to talk about slope and rate of change. We're just going to review that a little bit. So remember that the slope of a non-vertical line is the number of units that the line rises or falls for each unit of horizontal change. So here I've got a couple of lines that we're going to look at. We're going to look at the red one here first. Let's kind of slim this down a little bit here. So what I can do is I can pick a point that I know is on the grid. So like this point, this crosses right here, and this crosses right here. And so I can form a right triangle right here. Okay. And I'm going to call this point right here, I'm going to call this x1, y1. And I'm going to call this point x2, y2. And then that makes this point right here has the same x coordinate as this one. So this is x2 and has the same y coordinate as that one. So that's y1. Okay, so now what we can do is we can calculate this distance right here by taking y2 and subtracting y1. And we can calculate this distance by taking x2 and subtracting x1. Okay, this we call the rise right here, and this we call the run. Okay, this is how far we run for that distance that we rise. Okay, now we define slope. We use the letter M for slope as the rise over the run. Okay, so in this case, that would equal y2 minus y1 over x2 minus x1. So this is my slope formula right here. And it doesn't really matter if you do y2 minus y1 over x2 minus x1, or if you do y1 minus y2. You just got to make sure that if you do y1 first, that you do x1 first. You get the same answer. Okay, so let's say we've got some points here, and we know the points. Let's calculate the slope of this thing. So this, if we have a scale of 1 here, this would be 1, 2, 3, 4, 5. This is the point 0, 5. And this point right here would be the point, what is that? 1, 2, 3, 4, 5, 6, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay, so our slope then would be the difference in the y, so it would be 9 minus 5 divided by the difference in the x's, which would be 6 minus 0. So that's going to be 4 over 6, which reduces to 2/3. Slope is 2/3. That means it rises 2 and it runs 3. It's also positive, so that means it's going uphill. So this red line has a positive slope. It's going uphill from left to right. Now, we can do the same thing for the green line. Here, let's make this red so that we stay consistent with this. And now we'll look at some green. Okay, so let's say that we chose, let's see, we've got, I know it crosses this point right here, and then it looks like it crosses this point right here. Okay, so we could make a slope triangle out of that. Okay, and our slope triangle would go here. So this point would be the point 0, 2. This point would be the point 3. What is that, negative 5? 1, 2, 3, 4, 5, yep. Okay, so my slope then would be the difference in the y's, negative 5 minus 2, over the difference in the x's, 3 minus 0, which is going to be negative 7 over 3, and I can't reduce that. So that's my slope of that one. Notice it's negative. It goes downhill to the right. Okay. So we have our equation right here. You should know this equation. That's our slope formula. Now, it only works for non-vertical lines. And the reason it works for non-vertical lines is because if I have a vertical line, the x-coordinates are going to be the same. So I would end up with 0 in the denominator, which I can't divide by 0. Okay? Since I can't divide by 0, we say that that slope is undefined. Now, if I have a horizontal line, okay, that means that the y-coordinates are the same. That's fine. Because I can have a fraction where 0 is in the numerator, and I don't care what number is in the denominator, that comes out to be 0. So that means that the horizontal line has a slope of 0. Okay, so here's some slopes. Here's what you should be able to get out of this. You should be able to look at this and definitely tell me this slope is positive. You should be able to calculate it as well. Okay? This would be a negative slope. Okay, this would be a slope of 0. Okay, and this one, be careful of this one. This one has no slope. That's different than having a slope of 0. This one has a slope. The slope is 0. This one does not have a slope at all. Okay? This is cross-country skiing. This is dying on skis. Okay? So, no slope, or you can say it's slope is undefined. Either way, you're okay. Okay? But again, this one has a slope. The slope's 0. That one doesn't have a slope at all. Okay? All right, find the slope of the line containing the points -3, 4, and 2, 1. So I'm going to let you pause the video here and then go ahead and calculate this slope and then jump back on and see how you did. Okay, so slope formula, difference in the y's. So we're going to go 1 minus 4. And then on the bottom, we've got 2 minus -3. And I'm going to end up with -3 on the top. And I'm going to end up with 5 on the bottom because remember these cancel. And so my slope is 3/5. Okay, now I could have done it the other way if I wanted. I could have said, I could have gone 4 minus 1 over -3 minus 2. Well, that would just give me 3 on the top and -5 on the bottom, which is the same thing as that. Now, this would be one that was easy enough, too, that I could do a slope triangle right here, and I could count that I'm going down 3, so this has a rise of -3, and it has a run of 5, and so my slope is the rise over the run. So the rise is -3 and the run's 5. And again, I get the same thing. Doesn't matter which way you do it. You should know this formula, though, every time. Okay, theorem. Two lines are parallel if and only if they have the same slope. Okay, so you should be able to look. This is the easy one. This is a real easy one. You can look at two lines. Let's say I gave you lines y equals 2x minus 1 and y equals 2x plus 6. Okay, you can look at that and say, oh, the slopes are the same? Oh, these lines must be parallel. Okay, now if you get something like this, say y equals 1/5 x plus 2, and you've got, I don't know, how about 5, let's say x plus, no, x minus 5y equals 4. Okay. Now, this one you can't tell right away if those slopes are positive or negative, but what you can do is you can take this one and put it in slope-intercept form like that one. So I would subtract x, and I would divide by -5. And so I'm going to get y equals 1/5 x minus 4/5. And that would tell me, oh, these have the same slope. Okay. I got a slope here of 1/5. I got a slope there of 1/5. The y-intercept I don't care about. But that tells me that these are parallel. Okay. If they're not the same number, they're not parallel. Now, the other thing that you can tell is, are two lines perpendicular? So two lines are always perpendicular if and only if their slopes are opposite reciprocals. So what's an opposite reciprocal again? That would be like if one had a slope of 2/5 and the other one had a slope of -5/2. Okay? Those are opposite reciprocals. Or if one had a slope of -5 and the other one had a slope of 1/5. Okay? Or if one of them had a slope of 0 and the other one was undefined. Okay? Those would be perpendicular lines. Now, the other way you can think of it is the slopes will multiply together to be -1, except in this case. Okay, so on this, if I took 2/5 times -5/2, that'd be -10/10, which is -1. Here, if I take -5, make it -5/1, times 1/5, that's -5/5, which is -1. Okay? And like I said, this one you can't do because you can't multiply 0 times infinity. So, there you go. If it doesn't do either one of these, then all you can say is it's neither parallel or perpendicular. Okay, determine if the lines are perpendicular, parallel, or neither. Okay, well, I look at this one, I think, well, that looks to be perpendicular, maybe. How would I figure that out? Well, what I would do is I would take the red one. I've got 2 points here. So this one is -2, 3. And this, actually, you know what? I don't even have to do that. I can do this super easy. I can just look at the rise and the run. Okay? Here's my run. That's 5. Here's my rise. That's 1. Slope is 1/5. Okay? Then I can look at this one. Whoops, that's not a very good line, is it? Let's try it again. Let's make this a little narrower. Okay, so you go here. We're going to go here. Okay, so this is 2, and this goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is -10. So the slope is -10/2, but that reduces to -5. So 1/5 and -5, those are opposite reciprocals. Okay, so this implies that they are perpendicular. Okay, now let's look at this one. Okay. So this one, I can look at my slope triangle here. Okay, this one rises 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it rises 11. And it runs 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so my slope is 11/9. Okay, now this other one, this one here, I'm going to do my slope triangle right here. I don't know why that won't stay thin. Okay, my rise is going to be 1, 2, 3, 4, 5, 6, 7, 8. Oh. My rise is 8. My run is 1, 2, 3, 4, 5, 6. So my slope is 8/6, which is 4/3. Okay, those are not equal, so those are not parallel. They're obviously not perpendicular, so I don't have to worry about that. Okay. Now, these look like they could be parallel too. So this one, I'm just going to count. Okay, so my slope is going to go, it's negative, it's going to go down 1, 2, 3, 4, 5, 6, 7. And it's going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the slope is -7/12. Okay? Then I look at this one. This one's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 this way. And it's going to go down 1, 2, 3, 4, 5, 6, 7. So it also has a slope of -7/12, which implies that these are parallel. Okay? These are neither. Okay. Line A passes through the points 2, -5, and 5, -3. Line B passes through points -2, 3, and 2, 6. Are the lines perpendicular, parallel, or neither? Let's have you pause the video, do this problem, and then jump back on and see how you did. Okay, line A has a slope of -3 minus -5 over 5 minus 2. So this becomes plus. This is 2 on the top. This is 3 on the bottom. So line A has a slope of 2/3. Line B, 6 minus 3 over 2 minus -2. So that's going to be 3 over 4. Okay, so the slope is 3/4. Okay, they're not parallel because they're not equal. They're not perpendicular because they're both positive. Okay, and one's not the reciprocal of the other. So what does that imply? That implies they are neither parallel or perpendicular. Done. Okay, at 9 a.m., you're 25 miles from home. By 1 p.m., you're 245 miles from home. Find your average speed if you're traveling directly away from home. Okay, this is a rate of change problem. Rate of change and slope are the same thing. Okay, so I have 2 points here. I've got 1.925. And then I got to be careful here because this is 1. This is not 1/245. It's number of hours. So I could... that's 4 hours later, so this would be 245. The other way I could do is I could say this is times 0, 25, then this would be 4, 245. In fact, that would be easier to do. But we're going to go ahead and do this. Okay, so my slope is going to be my rate of change. It's going to be 245 minus 25 over 13 minus 9. Okay, so I'm going to get 220 over 4, which will reduce. So that'll go in there, what, 55 times? 20, yep, 55. So I'm going 55 miles per hour. Here's my rate of change. Okay, hopefully that's what you got. All right, I got a nice little assignment here for you. Enjoy that. I will see you guys later. Have a great day.